Welcome to our lesson on the quadratic formula and the discriminant. So in this lesson you're going to learn how to solve quadratic equations using the quadratic formula. And we're also going to talk about the discriminant, which will help us determine how many solutions we have and what type of solutions they are. In our last lesson we talked about completing the square, and we practiced that for a couple of days, so you should be familiar with that. And I'm going to show you, I'm actually going to derive the quadratic formula by completing the square on the standard form of a quadratic equation. So here we have the standard form of a quadratic equation where a, b, and c are integers, and they are the coefficients in front of my terms. And so if you remember the process for completing the square, we want to make sure that if we have a number in front of the squared term, or the quadratic term, we want to divide all of those terms by that coefficient. So dividing each term by a, I end up with this. And then we want to move, we want to move the constant term over to the right-hand side, so we're going to subtract c over a. And that leaves us with this equation. And then we're going to add a term to both sides. And the thing that we're going to add is half of the linear term squared. So half of b over a is b over 2a, and then we want to square that. So when we square it, we get b squared over 4a squared, and that's what we add to both sides. So now on this left-hand side, this is now a perfect square, and we can write it as a perfect square. So we're going to get x plus b over 2a, the thing we had before we square it, and I think I put that over here. So it's x plus b over 2a, the quantity squared. And then this right-hand side, we need to have a common denominator. So the first term on the left here, I multiplied by 4a over 4a to give us 4a squared. So this is a minus 4ac over 4a squared. So that's where this minus 4ac came from. That's this term right here, plus b squared. So we just switched the order of those. So I end up with this. Our next step is to take the square root of both sides. And when we do that, we get x plus b over 2a, because the square root and the squared cancel, equals plus and minus the square root of, we have the square root of the numerator, the square root of the denominator is just 2a. So we have that here as our denominator. And our last step is to subtract b over 2a. So when I subtract b over 2a, I get this. And since these have the same denominator, we can write that over one denominator, so we would have negative b plus and minus the square root of b squared minus 4ac all over 2a. This right here is called the quadratic formula. And the way that we want to read that, always think of this instead of negative b, think of it as the opposite of b, plus or minus the square root of b squared minus 4ac all over or divided by 2a. So this is the formula. You will be memorizing this. You need to know this. And we're going to be using that to solve problems.
Is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a.
So let's jump in. Here's an example where we're going to end up with two rational roots. So here's an equation, and we want to use the quadratic formula. So the first step is to put it in standard form. So the only thing we need to do to put this in standard form is to bring the 28 over to the left-hand side. So we're going to subtract 28. So here's our equation in standard form. Then we need to identify what a, b, and c are so we can plug those into our formula. Well, they go in order. A is the coefficient in front of the quadratic term, b is the coefficient in front of the linear term, and c is the constant term. And you keep the signs, okay? So a is positive 1, b is negative 12, c is negative 28. Our third step is to plug those values into our quadratic equation and then solve. So here's our quadratic equation. This says take the opposite of b. If b is negative, this number right here will be positive. plus and minus the square root of whatever b is squared minus 4ac over 2a. So I've substituted those in. Hopefully the colors help you see where the numbers came from. And then we're going to start simplifying. So just start taking it a step at a time. So the square root is the last thing you do. You got to get a single number under here. So we have positive 12 plus and minus the square root of 144 plus 112 divided by 2. So now when we simplify again, we get 12 plus and minus the square root of 256 over 2, which is 12 plus and minus 16 over 2. So now here's where we separate those. One of our solutions is 12 plus 16, the other one is 12 minus 16 over 2. So this one gives us 28 over 2, which is 14. The other one is negative 4 over 2, which is negative 2. So we have two rational roots, okay? So two rational roots, those are rational numbers. So here's an example where we will end up with one rational root. This happens when the value underneath the radical, the b squared minus 4ac part, is equal to 0. So here's an equation. We're going to go ahead and solve that. And so we're going to use the same process. So it's already in standard form, so there's nothing that we need to do. For step number 2, we're just going to find what a, b, and c are. And then we're going to jump right in and we're going to plug those into the quadratic formula. So here we have x is equal to, the opposite of b is negative 22, plus and minus the square root of 22 squared, minus 4 times 1 times 121 all over 2. So just keep simplifying. Each step you're going to simplify further and further. So 22 squared minus 4 times 121. We end up getting the same value here. Okay, so this is a 484 when we square 22, and when we multiply these, and when you subtract them, you get a 0, and the square root of 0 is just 0, so this thing drops out. So our plus and minus also drops out, and we just end up with negative 22 over 2, which is negative 11. So we get a single rational root when we get a 0 under the square root sign or under the radical. What about when we have irrational roots? So quadratic equations with irrational roots means that they have square root answers that don't simplify. And we always want to write those with the radical in the answer. We never want to estimate those and write the answers with decimals. So please leave your answers with either fractions or radicals in them. Okay, no decimals in this unit. So here's an example. It's already in standard form. So find what a, b, and c are. A is 2, b is 4, c is negative 5. Here we go. We're going to plug it into the equation, giving us this. And then go ahead and simplify. 16 plus, what is that? 8 times 5, 40. 16 plus 40, which is 56. And then split them up. So we get negative 4 plus and minus. This simplifies. There's a 4 in there. It comes out as a 2. So we get 2 square roots of 14. And then we have a factor of 2 here that we can go ahead and factor out. So if you factor out a 2 from the numerator, you don't factor it out of the radical, just out of what's in front of it. So we'll end up with a negative 2 plus and minus the square root of 14 all over 2. Now you can write that answer as negative 2 plus square root of 14 over 2 and then negative 2 minus square root of 14 over 2. I prefer just to leave it as that and recognize that you have two answers represented there. All right, so the last example here, sometimes we're going to get a negative value under that radical, and you know that we call those imaginary numbers. They are part of the complex number system. So whenever we get a negative under that radical, we will have two complex solutions. They occur in pairs. You'll never have just one complex answer. It's always going to occur in pairs. So here's another example. Standard form means we add the 13 to both sides. A is 1, B is negative 4, C is 13. Plugging it into the quadratic formula, we have this. And then go ahead and simplify that. We get 4 plus and minus the square root of negative 36 under the radical. And we can bring out the negative as an I, and 36 is a perfect square. So we get 4 plus and minus 6i all over 2. And then dividing each term by 2, we get 2 plus and minus 3i. Now, if we wanted to check this solution, we can take that and put it right back into our original equation, the x squared minus 4x is equal to negative 13 up here before we put it in standard form. And then just replace the x, anywhere there's an x, with 2 plus 3i or 2 minus 3i. So we're just going to check the 2 plus 3i. And so if I square that and multiply it by negative 4, we're going to check and see if we get negative 13. When we square this, we get 4 plus 12i plus 9i squared. And remember, I squared is a negative 1. So the plus 12i and the minus 12i cancel out. 4 minus 8 is negative 4. And negative 4 minus 9, when we simplify the I squared, gives us a negative 13. So we can see that that does check. You could do the same thing with the 2 minus 3i, and you would get the same value. So roots and the discriminant. What is a discriminant? Well, the discriminant is the thing under the radical before you take the square root, the b squared minus 4ac. That little piece of the quadratic formula is called the discriminant, and it helps us to figure out what kinds of solutions, the number, and what type of solutions we have. So I've included a table for you here that explains how you can use b squared minus 4ac to tell you what kind of solutions you're going to get. So if it turns out that that number under the radical, if it's greater than 0, or if it's a perfect square, we are going to get 2 real rational roots. So it crosses the x-axis. They could be whole numbers or integers. They could be fractions. They could be anything like that that's a rational root. If we get b squared minus 4ac greater than 0, but it's not a perfect square, it's still going to give us 2 real roots, but they will be irrational. Okay, if it's a perfect square, then they'll be real and rational. If it's not a perfect square, they'll be real and irrational. So things like the 2 minus the square root of 7. Okay, we could evaluate that using a decimal number, but it's irrational. If we get equal to 0 under the radical, I showed you an example, that's 1 rational root. Graphically, that looks like this, where whatever that root is the vertex, okay, of your parabola. And when we get imaginary roots, 2 complex roots, when we get the value of that discriminant is negative, so it's less than 0, and it never touches the x-axis. We've kind of talked about that. So this is the lesson where you can actually see graphically what's happening. If we have 2 real roots, it crosses the x-axis twice. 1 real root, the vertex touches the x-axis. And 2 complex roots means it never touches the x-axis. So here's 2 examples for you. I have 9x squared minus 12x plus 4. We want to find what the value of the discriminant is. So just the b squared minus 4ac part. We don't have to do the whole quadratic formula. So first of all, we're in standard form, so we can identify what a, b, and c are. And then just plug that into b squared minus 4ac. So in this example, b squared is 144 minus 4 times 9 times 4. And we end up with a value of 0. So we said that if the discriminant is 0, we have 1 real rational root. Look at example B. Okay, it's in standard form. A is 2, B is negative 16. Well, there's a typo there. B should be negative 16, and C is 33. Let me write that in there for you. This should be a negative 16. And so b squared minus 4ac gives us a negative 16 squared, which doesn't change our answer any. 16 squared is 256 minus 264, giving us a value of negative 8. When we get a negative discriminant, that means we have 2 complex roots. That's it for this video lesson. We'll see you in class.